Hello everyone. I'm so grateful to present in this World Higher Education Conference. My name is Neema Mduma, a lecturer from the Nelson Mandela African Institute of Science and Technology in Arusha, Tanzania. I'm also a winner of L'Oreal UNESCO Young Talent in Sub-Saharan Africa in the year 2020, and the founder of Bakishule Initiative, which aims at promoting science, technology, engineering, and mathematics to girls in secondary schools in Tanzania. My today's talk will focus on machine learning in education. Education in Africa faces several challenges, such as student dropout, which affects more girls than boys. Also, the issue of student textbook ratio, the shortage of classrooms, latrines, laboratories, etc. So how can we use emerging technologies such as machine learning on addressing these challenges? That is the question which I posed during designing of my PhD research. So I decided to work on student dropout problem, which is one of the biggest challenges facing many secondary schools in Africa. Despite many initiatives such as free secondary education in Tanzania, student dropout is still high and is linked to factors such as school distance, early marriage or early pregnancy, household level activities, parental investments, and so on. Addressing this problem of student dropout requires a deep understanding of underlying causes and a better plan for intervention. Therefore, a machine learning model was developed using student-level datasets in order to understand to what extent different factors contribute to the student dropout problem. Also, the model was trained to identify and predict students who are at risk of dropping out of schools and suggest proper measure for intervention. To achieve this, the study used publicly available datasets, which was collected by non-government organizations for the aim of assessing children's learning levels in Tanzania. The datasets consist of 18 variables and about 61,000 samples. So the first step, we check for the dataset distribution, and we observe that our dataset was highly imbalanced, as you can see from this figure here, where it was only 1.6% of the students who were dropouts. Data imbalance is very common in the field of student retention. This is because the number of registered students is always high compared to the number of dropout students. And developing a machine learning model without considering data imbalance may result on having a generalized model. Therefore, different techniques were applied in order to handle data imbalance problem, including rules for undersampling, Ross and Smart for oversampling, Smartin and Smartomic for hybrid, in order to make sure that we are handling the problem of data imbalance. Also, data preprocessing were applied through data cleaning, integration, transformation, and reduction. And this was done in order to ensure that our data set is well before model development. We also check a feature selection experiment in order to understand which features show strong contribution to the dropout prediction. And the results show that student gender, parent check child book, and meals per day were the three factors which show strong contribution to the dropout prediction. This is contrary to what is perceived by many people in the society who tend to link student dropout problem with obvious and direct factors such as school distance, early pregnancy, and ignore other factors with indirect link to the problem. The next step was to develop a machine learning model where 4 machine learning algorithms were used, which are logistic regression, multilayer perceptron, k-nearest neighbor, and random forest. And we evaluate performance of this model using evaluation metrics, which are F-measure, adjacent geometric mean, and geometric mean. Then the results show that logistic regression and multilayer perceptron showed the best predictive performance. So what we did is to tune this two well-performed model using optimization techniques, and then we apply stacking techniques by softly combining the tuned logistic regression and tuned multilayer perceptron in order to come up with the ensemble model. And then ensemble model shows that it performed well compared with these other two models. So next step was to deploy a well-performed model, which it was our ensemble model, in a web-based application called Bakishule for education stakeholder to easily identify and predict students who are at risk of dropping out of school. 6 features which show strong contribution to the dropout prediction were used as input information. As you can see in this platform, for example, the gender were female, the age 21, meals per day were 3. About reading book status, the input was student does not read book with parents. And in the part of the parents review status, it shows that parent checks student's book once. And for the parent-teacher relation, it shows that parent discussed with teacher on student progress. And the status came out to be dropout. So Bakishule has been able to correctly and identify students who are at risk of dropping out of school and suggest proper measure for intervention with the accuracy of 85%. Despite the success of the developed model, these are some of the challenges that I faced. Starting with the issue of data. Many data in developing countries are not in a digital form, so it took a lot of time and cost to digitize them. Also, many data are not available in a public repository. The second challenge is the shortage of experts in the field of artificial intelligence. As we all know that this is an emerging field, especially in developing countries, so at some point we need technical assistance from outside. And lastly is people's perceptions towards artificial intelligence, because some people are still not believing on the power of this technology on solving different challenges in the society. In the future, AI may change education system for the better. In Africa, challenges such as student dropouts can be addressed with the help of this technology. Since student dropouts affect more girls than boys, addressing this problem means more girls will attain education and help in gender inclusion in Tanzania. And also, we are going to help to improve and attain sustainable development goals. Thank you very much. Question?
Sorry. I don't see you.
Thank you very much, ma'am, for inspiring presentation and all the work that you have done in advancing machine learning in Tanzania. My question really relates to when exactly the study was conducted, how long did it take, what's the participation level in terms of government support for advancing especially education for young women, given all of these challenges? Thank you.
Okay, thank you very much for the nice question. So this study was conducted when I was doing my PhD, and I graduated in 2020. So I started in 2017 and up to 2020 is where I finished this study. I took it for 3 years. And as I've explained, when I was conducting this study, I faced several challenges, including the issue of data sets. Like for my case, it took like 1 year to find the data set to work on this study, because most of the data sets are not available in a digital form, and you cannot even just go to the repository and find the data set that you can use. But through the government and a non-government organization, I was able to secure the data set which was collected for the aim of assessing the children's learning level in Tanzania. And the government in Tanzania, they are doing a lot, including currently they have started to collect different data sets, and they are now available in the digital formats, but most of the data sets are in the school level. So in case you are interested to conduct a study, which it is focused on the student level, when I say student level, it means you want the data set of individual student. It's kind of challenges. But when you want to conduct a study in the school level, currently the accessibility of the data is started to be improved and the data is available. So those are some of the challenges and the way forward, but in short, the government have done a lot in order to improve education, especially for the girls' education. For instance, even here currently there is support for students who are studying science. They have got a loan which is different from other gender when you're talking about male students. So there are different initiatives which has been done in order to ensure that they are going to improve education, especially for girls. Thank you.
Thank you so much. This was a very interesting presentation. Could you please tell us a little bit more on further applicability of this approach or an instrument that you developed and how it is being further helping to increase the participation rate of students?
Okay, thank you very much for the very nice question. So currently this application, it's called Bakishule, which is a Swahili word for stay at school. It has been used in several secondary schools in Tanzania, in 5 regions, 5 districts which we work with in Tanzania. And the challenge is we were not able to reach all schools, as we all know that there are so many schools in Tanzania, but we have tried to reach about 31 schools in those 5 visited districts when we are conducted this study. And so far we have about 357 active users who are using this application. And it includes different education stakeholders such as parents, teachers, and education officers, who they can now use this system in order to understand, based on the input information, if the result is going to come as a dropout or not dropout, and what can be done in order to rescue the situation. So currently the Bakishule, it has been able to correctly identify and predict students who are at risk of dropping out with that accuracy of 85%. And we are hoping that if we'll be able to reach more schools, we'll be in the position even to improve the performance, because as the more the model receive more data, it keep on learning in order to improve the predictive results. Thank you.
Thank you, Neema. Given the success rate, you mentioned 85% predictability, are there plans to do a follow-up study on those students that have been retained as a result of the model or the application?
Yes, we have started to apply different intervention program, especially for those students who were identified as a dropout student. So once the system has been able to identify maybe a certain A student is about to drop out, different intervention programs has been established in order to understand the situation. And the good thing is when you input those information, it just give out the predictive results, and you can understand from those results, maybe based on the input information, it could be maybe the parent does not check the child book. So it could be easier for you as maybe a parent to understand what are the things you need to improve in order to help your student not to drop out. So those are the things which have been able to be identified as one of the goal of this study, as one of the objectives is to understand what are the features or factors that contribute significantly to the problem. So we have been able to identify those factors, and then once it happens that a certain age student is about to drop out, we just look on the factors that might highly contribute to that problem in order to rescue the situation. Yeah.
So I have a follow-up question. I represent a SIDS in the Caribbean, and we do have Dominica, and we do have universal secondary education, which in itself poses its own challenges. How did, based on your study, how did stakeholder buy-in take place, especially with parents, and making sure that, because if they're not following up or on board with checking the students' work or inputting the data, that would limit your success, right?
Yeah.
How do you get stakeholder buy-in and involvement?
Okay, so thank you very much for that question. It is very interesting. And most of the time, stakeholders, for instance, parents, we always meet with them once we visited a certain schools. We always arrange a special meeting with the parents in order to introduce the application, because this is the new application. And not only a new application in Tanzania, it's also a new in form of the technology which has been used. So first of all, we have to introduce what is machine learning to people for them to understand the technical part behind the application, and then to make them understand how they can interact with that system. So that is how we have been done in order to reach out different stakeholders, including parents, through different schools which we have been visited. And so far, between active users, the percentage, about 70% of the users of this application, they are parents. Yeah. So that involvement for the part of the parents, it has been well successful. Yeah.
Thank you. How much funding do you have available to you when the issue is that meals on tables is the reason for the dropout? So you talked about intervention, but actually, and talking to the parents, but sometimes it will come down to funding, right?
Yeah, thank you very much. That is very interesting issue. And we have met with kind of things when we reach to different stakeholders, because sometimes you can find the issue of meals per day, it's the issue of investment of the parents, the income. So in the areas like that, we are going to, we have come up with different initiatives, like programs, which support, it's called community-based support, whereby different schools in Tanzania, some of the schools, they've decided as a parent to find a way to ensure that students have food, meals at school. So it's kind of a small contribution which it is always done within the community in order to ensure that everyone gets the meals. So that is kind of things which we have decided to propose, and it has been worked to some of the schools, and we have been able to reach the target of addressing that issue of meals per day. Yeah. Thank you very much.